Welcome back. This is still the plenary session in GRA6036, and we are working with the final exam from the spring of 2019. And in the first video we did assignment 3A, and now we're doing assignment 3B. So we are being told that a second degree polynomial like this, with A strictly positive, attains its unique minimum in this point. We're not asked to show this, but this is information that it can be clever to write down before we attack the exercise. So let's note that down. So here we are. So we have, we can just write it quickly. So we have a second degree polynomial so this is the function. Okay, and we are being told that with A0 strictly positive. Okay, so that we can now see here. Attains its unique minimum in point x equals minus a1 to a0. Okay, so this is the information we are given in the exercise. Then we're asked to show the following. So we're given some numbers, so we can think of this as data, and we have this function, which we recognize as the function we minimize when we do least squares estimation. So already you should sort of know what the answer to this exercise is, but there is still, even though you know the answer, so what the value of b0 that will minimize this function, there is something to do in this exercise, because we are to identify the numbers a0, a1, a2, so that we can write this function like this. Okay, so when we have it on this form, we will associate b0 with x, and then we can use this to find the minimizer. Okay, so let's write down. So we have some data, or just numbers. So some observed data, and here are our data, and then we have this. We'll write down the function that we are going to minimize, and show that this function is a second degree polynomial, and then use what we know about it, or the information we're given, to find the minimizer. So f evaluated in b naught is the sum from I equals 1 up to n of yi minus b naught squared. So this is the function. So this is the function, and I'm sorry, I thought I paused the recording here. And now we can work on this first term here. So expand the squares. So we can still use some parentheses. We get yi squared minus 2yi b naught plus b naught. Okay, so you can see what I've done here. So we still have the sum outside. Now we can take the sum inside. So we take the sum inside the parentheses. So for the first term, there was not really that much to do in a sense. I mean, the first term is the sum of the yi squared for the second term, we see that there is this constant that will go outside the sum together with this constant and the minus sign, of course. And when we sum these yi's, we know that that is equal to n times the mean of the yi's. So we get 2 b naught times n bar yn. So now I have a double, get this. And this is because, I mean, we can write that down here because, as you remember, the sum of the yi's is equal to the mean, to the n times the mean of the yi's. So we can note that. Now that's down here right now. So this equality you remember, and it follows directly from the definition of the mean. So I mean, you can see it by moving the 1 over n over, because 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 bar yin is defined to be 1 over n. So because, but anyways, so here is it. So that's what we used up here, and then we get plus n times b naught, because we have n of these appearing. Okay, so now we see that it starts to look like what we have up here. It might be even easier to see if we rearrange the terms a bit so we get them on the same form. So we see that do you now see what I forgot to do? I forgot to square this last term here. That happens. So now this is correct. Okay. So if we rearrange this expression a bit, so we get it to look like this expression, it will be easier to see. So we write n times b naught squared minus 2 n bar y n b naught plus the sum from I equals 1 to n yi squared. So now it's easier to see, because if we compare these two, we see that we have this in parentheses here. So we now see that, well, so a naught must be n. Okay. So this is just by comparing these two expressions. So a naught must be n, a1 must be minus 2 times n times the mean, okay, because b naught corresponds to the x here. So a1 is minus 2 n bar yn, and then lastly we have that a2 must be this sum. So now we identified a0, a0, a1, where there's supposed to be a minus in front. And the reason for there being a minus here is because all these are pluses. Okay. So now we identified these terms, and we also see, so we see that the sample size is positive, so A0, which is equal to n, is strictly positive, which is one of the requirements up here. So now we can use this formula to find the minimizer of this function. So remember that x corresponds to b0. So if we plug that into our, now we're going to use this formula to find the answer that you knew already. So we have minus a1 divided by 2a0. Now we insert what we found here. So a1 is equal to minus 2n, the mean of the y's. So which means that, so we get a minus minus, which is plus, and then we have 2 times a0, so it's 2 times n. So we replace this by n. We get this, and now we see that the 2 times n falls against 2 times n. So this is then equal to the mean of the y's, which we knew already. And I think that was the exercise. So in the next video, I'll do some more math exercises from another previous exam.